This part you agree with? Okay. Now that you agree with this part, now see, this is the, look at these two triangles. This triangle, in the book they have done it in a very complicated way. Okay. This is a triangle, and this is another triangle, right?
Yes, sir.
And these two triangles are similar or not? Class 10 similar triangles. Yes. If you call this as A,
Sir.
B, C, D, and E. So triangle ABC is similar to triangle ADE. Do you agree or not? Class 10 knowledge.
Similar. Yes, sir.
Are they similar?
Yes, sir.
If they are similar, then what can you say about the proportional sides? Then you can say that BC by DE must be equal to AB by AD. Sides are proportional.
Yes, sir.
That means what is BC? BC is small r. What is DE? DE is capital R. What is AB? AB is capital H minus H. Right? Because this height is what? This length. Capital H minus H. Right?
Yes, sir.
And AD is what?
Yes,
AD is
sir.
capital H. Right? So you've got a relation between R and H. Now what happens? Let me find R in terms of small r in terms of small h. You get R by H times H minus H. Right? Will you get this or not? Yes?
Yes, sir.
That
Yes,
means
sir.
this is my auxiliary function. Let us call this one. This is my auxiliary function. Now what is my maximizing function here? Volume of the cylinder. Let us now find the maximizing function. What is the volume of the cylinder? Let us call it V as the volume of the cylinder. Volume of the cylinder is, what is the formula for volume of the cylinder? Do you remember? Do you remember volume of the cylinder?
A
Yes,
volume
sir.
of cylinder.
Sir, one third. Sir, 1/3 pi
Wrong.
r square h.
Pi r square h, not 1/3.
Yes, sir. Pi.
Pi r square h.
Oh,
So pi, what is
oh
the
yes,
radius of
yes,
the
sir.
cylinder?
Pi
Radius
r
of the
square
cylinder
h.
is small r, right? Pi r square,
Yes,
it
sir.
is pi r square h. Volume of the cylinder is pi r square h. And what is the radius of the cylinder?
Yes,
It is
yes,
small r. So pi r square. And what is the height of the cylinder here? The height of the cylinder here is small r, small h, right?
yes, sir.
So now with the help of this auxiliary function, we are going to put the, see, I have two variables here, small r and small h, right? So we need to bring out down to a single variable. So this auxiliary
Yes,
function
sir.
of mine, we'll put it here and then bring it to a single variable. Okay. So let us put
Yes,
it
sir.
here. Pi r square means r by h into h minus h whole square into h. Now it has come down to a single variable, isn't it? Because r and h,
Yes,
capital R and capital H are constants, right?
yes, sir.
So now what will happen?
Yes, sir. Yes.
This will become pi r square into h minus h whole square divided by h square, right?
Yes, sir.
Or you
Yes,
can
sir.
write this as, take the constants together, pi r square by h square into h minus h whole square. Why did I write this way? So that I know that all this is constant. Okay. So now for local maxima or minima, what happens? No, first we find the first derivative, right? dv dh.
Sir,
Yes.
sir. Sir, into h was also there.
Yes, into h is also there, no? Yes.
Yes,
So
sir.
let us write the h here. Okay. So let us simplify this so that it is easier for us to differentiate. The pi r square by h square we write as it is, and here what we do is we expand this. H square plus h square minus 2hh into h, which is equal to pi r square by h square into h square h plus h cube minus 2h h square. Right, now it will be easier for us to differentiate. Therefore, what is dvdh? dvdh is, you take pi r square pi h square constant into ddh of h square h plus h cube plus 2h, sorry, minus, not plus, minus 2h h square. Capital H is constant, remember. Okay. Pi r square by h square, pi r square by h square. Now, if you differentiate this, you will get what? H square. ddh of h is 1 plus 3h square minus 4hh. Okay, this is what we get. So for local maxima or minima, what happens?
Yes, sir.
For local maxima or minima, dvdh is equal to 0. For local maxima or minima, dvdh is equal to 0. That means dvdh is equal to 0 means pi r square by h square into h square plus 3h square minus 4hh is equal to 0. Right?
Yes.
Okay. And therefore, from this we'll get a relation between small h and capital H. That means we are getting h square plus 3h square minus 4hh is equal to 0. Okay. So that means 3h square minus 4hh plus h square is equal to 0. How do you get a relation between h and h? You can solve this equation by Sridhar Acharya. Therefore, what is h? H is equal
Yes,
to
sir.
minus 4h plus or minus
Yes, sir.
root over of
Root under
minus
b
4h
square,
square
that means 3. Yes,
minus
sir.
4 into 3 into 1 into h
AC.
square, sorry, not 1, h square divided by 2 into 3.
Minus
Right? What are you getting here? 4h plus or minus root over of 16h square minus 12h square divided by 6. So you are getting 4h plus or minus 16 minus 12 is 4h square, and square root of 4h square is 2h.
yes, sir.
Right? So what are you getting?
Yes, sir.
That is either h is equal to 4h plus 2h
2 1.
by
Sir,
6,
h by 3
which is equal to capital H,
or
or
h.
h is equal to 4h minus 2h.
Sir, h by 3 or h.
Yes. So this is 2h by 6, which is h by 3. Now h by h is equal to h is not possible, right? Is it possible? Can the height of the
2h.
cylinder be equal to the height of the cone?
Yes, sir.
No.
No, sir.
So h, since
Yes, sir.
h not, can the height of the cylinder be equal to the height of the cone?
No, sir.
It cannot be equal. So therefore,
No,
No,
sir.
sir.
h equal to h is not possible, right?
So it will be 2h by 3.
Therefore,
No, sir.
Yes, therefore at h is equal to h by 3, at h is equal to h by 3, v is maximum, v has a maxima or minima, right?
Yes,
V
sir.
has a maxima
Yes, sir.
or minima, right? Now whether it is a maxima or minima, we'll check with the help of second derivative.
Yes,
Now what
sir.
is my first derivative here? First derivative here is this. So we start from here. So dv dh is equal to, we have dv dh is equal to pi r square by h square into h square plus 3h square. In fact, let me write it in the, yes, h square plus 3h square, h square plus 3h square minus 4hh minus 4hh. Okay, this is what we have. Therefore, what is d2v dh2? d2v dh2. You differentiate this once again. You take pi r square by h square, a constant out. And once you differentiate this h square is constant. So this is 0. If you differentiate this, how much do you get? 6h. And if you differentiate this, what do you get? 4h is constant. You simply get a 4h. Right? So what do you get here effectively? You are getting 6h. You're getting here 6h minus, or let me take 2 common from here. That will be more convenient. Twice of 3h minus 2h divided by h square and 2 pi r square. In fact, this is 2 pi r square. 2 pi r square into 3h minus 2h by h square, right? This is what we are getting, d2v dh2. What is the value at which we are getting the maxima or minima? Let me check the sign. At h is equal to h by 3. What is the sign here? d2v dh2. Just put it here and check the sign. Is equal to 2 pi r square. Put the value of h, small h, 3 into h by 3 minus 2h divided by h square. So what is the sign here? This 3 cancels, right? So what is the sign you are getting? H minus 2h, right? This is positive. H minus 2h is what? Negative. This is positive. This is negative. This is positive. So what is the sign? Yes, tell me, what is the sign?
Sir, positive.
Why positive? H minus 2h. This is negative.
Two. Yes, sir.
H,
Yes, sir. Negative.
this has to be negative, right?
Yes, sir.
So therefore,
Yes, sir. Negative.
at h is equal to h by 3, we get a maxima or a minima. V is maximum, right? Because second derivative is negative.
Yes, sir.
So V is maximum. And what have they asked you to show? Our proof is complete. What have they asked you to show? Show that the height of a cylinder of greatest volume which can be inscribed in a right circular cone has 1/3
Yes, sir.
that of the
Maximum.
cone. So what do you see? H is equal to h by 3. That means height of the cylinder small h was the height of the cylinder is equal to 1/3 height of the cone. When V is maximum, That's it. You have shown that the height of cylinder is 1/3 the height of the cone. That's it. We stop here for today.